Hello and welcome. In this video, we'll look at data augmentation using TensorFlow. And there are two approaches. One is using Keras preprocessing layers, which are resizing, rescaling, random flip, random rotation. And there are tf.image methods, which is flip underscore left underscore right, RGB to grayscale, adjust brightness, central underscore crop. And this particular example is directly from the docs. This is the link for that, and I'll be simply copying the code from the docs and explaining it here. So let's first get started with importing the libraries. So we need first we'll import matplotlib. So mat.lib.pyplot as plt. Then we need numpy. So import numpy as np. We need to import the TensorFlow. Import TensorFlow as tf. Then we need to import TensorFlow datasets. So import TensorFlow underscore datasets as tfds. And finally, from TensorFlow.keras, we can import the layers as such. And so once we have imported the libraries, we can now download the flash dataset, which is tf underscore flash dataset. And to that, let's create a heading download a dataset. And this is going to be a markdown. So why don't we copy that? So what I'm going to do is create another text cell here, that in there. And now we can go ahead and download the dataset. So do that, we can we'll get a tuple with three values: train underscore ds, that's the train set. Then we have validation set, the val underscore ds, and then we have a test set, test underscore ds, and then a comma metadata. So we get the metadata for the data set that we are downloading, and then we can say tfds.load, open close parenthesis, and within this we can write the name of the data set. This is tf underscore flash, and then we can specify the split for the data. So in this case, we'll split the data set like so, where we have the train part, so that as the 80% is goes in the train set, and that's the string we are specifying, and then comma, we specify another string for the validation set, and then we specify another string here for the test set. And finally we'll close that bracket there, and that's the splits that we'll have for each of these strings. So for train we specify that, then we specify this value here and this value. I'm just copy pasting that. Now the percentage is what we are going to vary. Here we'll say 80% to 90%, that goes in the validation set. So that's the 10% there, and then the remaining 10% goes into the test set. So here we have 80, the rest of 20% split in between the validation and the test set. Then we also are going to say for with info is equal to true. So we need the information about the metadata, and that's a comma there. As underscore supervised is equal to true. And so this is how we have now downloaded the data. Once we have the data, we can now look for what's in the data. It should have 5 classes, so we can check that by saying num underscore classes is equal to metadata dot features, and then we say label and dot num classes underscore classes. And if we print the number of classes, num underscore classes, we see that there are 5 different classes in this particular data set. And we can look at the image of the this is a Flash data set, so we can look at the image of a flower, and we can get the name or label associated with that image, what type of flower it is. So first we'll try to get the name, and to get the name we can say metadata dot features label, and then we can say dot int to string, and this is going to give us the name of the this is going to give us the this class label for uh, this particular int, from this int to string, and going to put that in a variable get underscore label underscore name is equal to, and now we can iterate over this. So we can say image comma label is equal to next, and then say iter train underscore ds, then we can say underscore is equal to plt dot im show image, that we get the image from the train dataset. Then we can put the title plt dot title get underscore label underscore name, using the label that we get using the label. And so when we run this, we should get an image which is seen here, that these are the flowers, and the title associated with this particular label is tulips. Once we have uh, s- uh, this kind of data downloaded, and we have seen one sample image from the dataset, we can now use the Keras preprocessing layers for performing the augmentation. And so here what we'll do is we'll give another heading, Keras use Keras processing layers, and then the first thing we'll do is resizing and rescaling. So in here again we can declare a global variable img underscore size is equal to 180, and then we'll describe a sequential model and put it in the variable resize, and rescale is equal to tf.keras.sequential open close parenthesis open close square brackets, and here we can say layers dot resizing, and inside of parenthesis we say image underscore size comma image underscore size, so that's the size of the image we would like it to be, and then layers dot rescaling 1.0, so we are dividing the pixel values by 255, so this is 1 point that's converting it to float, and then we have the divided by 255. So that's the model we have created, sequential model, and now we can use that. So we can say result, so that's where we store the output of our resizing and rescaling. Result is equal to resize underscore and underscore rescale, and we input an image to this particular function or model, and then we can look at the output. Underscore is equal to plt dot im show result, and in the output we should see the image which is here, and we can see that this is a resized and rescaled image that we are seeing right here in the output. Now in this particular image we can check what are the minimum and maximum values of the pixel. We see that it was resized, so if we go back up, you see that this is 180 is the image size, and earlier the x and y axis were up to 400, and this was above 400. Now because we rescaled it to a square image of 180 by 180 pixels, See that the x and y axis are at 180 by 180, and it's a square image, so the image got squished a little bit. Additionally, we also did some rescaling, and we can check the values for that, and we could print out the values. So let's say we print and we say min and max pixel values, and then we can say comma result dot numpy. So it is an array, so we can get the minimum value from the array, and then we can get the maximum value from the same array. Result.numpy, and again we get the max value. When we print this, we should see the values that are, so here we see that the values are now between 0 and, so that's how we did perform on image augmentation. We augmented the image, we created this image which is now resized and scaled. Next, we'll now look at, so this is, you could argue that this is just pre-processing and not an augmentation as of yet, but we'll do, this could be a pre-processing step before we perform the flipping and rotating the augmentation part of. So for data augmentation then, is data 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 augmentation, and now we'll again create a keras sequential model and call it data underscore augmentation is equal to tf.keras.sequential with a capital S, sequential, and open close parenthesis, open close square brackets. Within this we'll write layers dot random dot flip, and within quotation we'll say horizontal underscore and underscore vertical. So that's one augmentation, one change, and then layers dot random rotation 0.2, and that's the model we have. So if we run this, we have the model. This is random flip. There shouldn't be a period there, just random flip. Okay. Now let's get started with the actual image augmentation part. And first thing we'll do is we'll take an image and add it to a batch. So add the image to a batch. Here we have the image, and we are going to use the tf dot expand underscore dims, and we specify comma 0 here, and after this we are going to cast this as float. So again we put that in parentheses, tf dot cast, and here we can specify tf dot float 32, and this will store it in a variable called image. So with that we can now plot these figures. So we can say plt dot figure, and fig size is equal to 10 by 10, and we'll use a for loop for I in range 9. So we have we'll create a 3 by 3 grid, augmented underscore image is equal to data underscore augmentation, and we use the image here, and finally you can plot it. Ax is equal to plt dot subplot 3 comma 3, that's 3 rows and 3 columns. We have I plus 1, and then plt dot im show, and here we use the augmented underscore image, and we use the index 0, and say plt dot axis off. And now when we run this, we should see a 3 by 3 image, so there's some error, but what that is. Exception encountered when calling layer random flip. So let's go back up and look at what random flip we have. Layers dot random flip, and we have horizontal underscore and underscore vertical. Then we have rotation, which is 2, and here we are passing the image data augmentation, and wondering what the error is. So we have random rotation, random flip. The image is tf.cast, tf.expand underscore dims, image, comma 0, tf.float 32. I think looks okay to me. Let's copy this and run this by itself and see what error we get. Should be the same error. Yes, and it says colors is so inputs tf.tensor shape is this, so it's the shape error. So what I'm going to do is if we can go back up and rerun this. So run this again, run these cells back down, augmentation part, and see what we get. Okay, so I think there was I just had to rerun the cell. So what we have now is these are the images that we have. These are rotated and flipped images. From one image we created 9 different images that can be used for training purposes. Now pre-processing. So just as we did the pre-processing, there are we can move a step further in this, and you can see there are two options to use the Keras with the capital K, Keras pre-processing layers. And let's look at option 1. Option 1, we can put these rescaling, resizing, and augmentation inside of the model itself. So like so, model is equal to tf.keras with a capital with small lowercase k, keras dot sequential, open close parenthesis, open close square brackets, and here we can add the pre-processing layer. So we can add the pre-processing and augmentation layers here. We can do that, and we can say resize and rescale. That's the one, and the second one we had was data underscore augmentation. That's the second one, and then we can use our conf2d layer. So conf2d, and we have 16 comma 3 padding is equal to same, and then we have activation is equal to relu, and finally we can have a layer after this. Layers, there should be a layer with a s, layers dot max pooling 2d, and so on. So this is how the rest of the model below. So this is how this is just to show that we can create a sequential model, and the sequential model can begin with the pre-processing or data layers or steps, and then the augmented image set would then be used as an input to the subsequent layers. That's one option that we can do, and the other option is, so if you look at option 2, here we can apply. So let's put that in comments. Apply the pre-processing layers to your data set directly. Right. So here we can say augmented data set is equal to train underscore dataset dot map. We are using map, and then use a lambda function, lambda x comma y is equal to, those are the input arguments, and we say resize and rescale x comma training is equal to, and that's followed by y. So that's another way in which we can perform augmentation, which is the first case we applied it inside of, we specified it inside of the sequential model. The second case, we directly applied it to the trained data set. Now we are going to put it all together. So let's give this heading, apply the pre-processing layers to the data sets. And we need this to be text. Copy, create a cell, that's text cell. And what we are going to do is create a function that that calls all the functions we created above to perform all the pre-processing, and also create batches. So we'll say batch size is equal to 32, and we'll say auto tune is equal to tf.data.auto tune. Okay, with that, now we'll create a function prepare that takes in data set, and we'll specify shuffle is equal to false as default, and augment is equal to false as default. And inside of this, we'll we'll call resize and rescale functions, and we'll apply that to all the data sets. The second thing we'll do is uh, we'll uh, we'll check for shuffle, so check shuffle, and then after that create a batch all data sets, and then we'll perform the augmentation. So use data augmentation only on the training set, and then we are going to uh, use the buffered prefetching on all the data sets. Use buffered prefetching on all data sets. So let's go through this one by one. First thing we'll do here is say ds is equal to dataset is equal to dataset.map, and we use the lambda function that we used just now, lambda x comma y is colon, we will call resize underscore and underscore rescale x close parenthesis comma y, and outside of this then we can specify num underscore parallel with ra parallel underscore false is equal to auto tune. Okay, so that's part one. Then for checking for shuffle, we say if shuffle, so if shuffle is equal to true, then do this, which is ds is equal to ds dot shuffle 1000, and if it's default it's false. So there just looked at this, this is auto tune, made a typo there. Okay, shuffle again, another typo here. So we have if shuffle is equal to true, then it will come down and it will shuffle the data set. Then the next thing we have is batch. So ds is equal to ds dot batch underscore size. And finally, what we have is if augment. So if augmentation is true, if we want to perform the augmentation, we say ds is equal to ds dot map, same as before. We say lambda x comma y, and here again we specify what operation we want to do, and then after that we are going to say num underscore parallel underscore calls is equal to auto tune. the same as above. The only thing that will change here is the model that we are calling from Keras. Data underscore augmentation and x comma training is equal to true. That's what we are going to call data underscore augmentation. Finally, we are going to return, and so return ts.prefetch buffer underscore size is equal to auto tune, and that's our function. That's the function we created, which we can use now for to kind of reprocess and augment all our train validation and test it. And say train underscore ds is equal to prepare train underscore ds comma shuffle is equal to true and augment is equal to true. Likewise, for validation dataset, we are going to say prepare validation underscore ds and then likewise test underscore ds dataset that is ds. We are going to say prepare test underscore ds, that's dataset, and so that's how all the train validation and test sets would be created. So map cotton as a num underscore parallel underscore call. Let's look at what that is. Again, there should be an s after the call. There, we run these two again. This will create the pre-processed augmented data sets. And once we have those, we can now go ahead and train our model. So let's create another cell here and call this train a model. And for this, again, we can use Keras sequential layers. Model is equal to tf.keras.sequential. Again, open close parentheses, open close square brackets, and here we provide the layers. Layers dot conf2d. So it's a stack of conf2d and max pooling layers. So conf2d, and we have 16, value of 60 here, 60, and padding is equal to same. Then for activation is equal to the relu function, and the next relu lu. After this layer we have the max pooling layer. So layers dot max pooling 2d open close parenthesis. So this is what we have, and I'm going to simply copy this a couple of times to create our model. So let's is that here one, then I can put that here 2 times. I will change few values inside of this. Change this to 32 by 3, and this one let's change this to 4 by 3, and final after this one we have flatten. We can flatten the output of earlier layer. So layers dot flatten, and then we have layers dot dense 128 comma activation is equal to relu, and after this we have layers dot dense num underscore classes. So that's our model, and we can run this and see that our model is good. We can now compile the model. So for that we use model.compile optimizer is equal to Adam, comma, and then we have loss is equal to, we'll use the sparse categorical cross entropy tf.keras.losses dot sparse categorical cross entropy, and specify from underscore logits is equal to true, And finally, for matrix, we have matrix is equal to accuracy. So that's so when we run this, it should so we have compiled the model, and now we can train it. So we can train for a few epochs. So train for a few epochs. Epochs is equal to 5. We'll set the value to 5. History is equal to model.fit open close parenthesis, and inside of this we specify the train data set. We specify the validation underscore data is equal to, so that's going to be a validation data set, and we specify epochs is equal to epochs, and when we run this it should start training, and there's an error, so let's see what the error is. Okay, so I've figured out what the problem was, and the target is missing, and that's error on my part. In here in the function where we call the data augmentation, and after this we should have specified the y, and now when we run this, this should now work. Some error again. Required positional argument y, and see why that's the case. We have the train underscore ds is equal to prepare train underscore ds data augmentation x training is y, that y there. Oh, I think we may have to go back up and rerun these cells. We go back because we need the train data set again. So I'm going to run all of these again, and hopefully this work. Yeah, so far so good. Yes, so this is working now. So the error was that up in the function, I forgot to specify the y. Now this will continue for 5 epochs, and we have the accuracy and loss for each of, as we can see how it changes in each of the iterations, and as the epochs continue, you should see that the validation loss goes down and the validation accuracy starts to go up. So I'll cut the video here and come back when the run is done. Welcome back. Here the run is done, and we can see the epochs. We have gone through 5 epochs, and on the right hand side we can see the validation accuracy, and it is 0.6485. Now what we can do is test this model, run this model on the test data set, and see what accuracy score we get. For that, we'll type loss, comma, accuracy is equal to model.evaluate test underscore ds. So that's the test data set, and print accuracy colon comma acc, and we should see the accuracy for the test data set, and it's yeah, it is about the same. It's 0.65 and 0.656485. So same as what we had for the validation. Next, let's look at how we can use custom methods to do image augmentation. So let's create another heading here. Custom data augmentation. And what we'll do is we'll create custom functions that will do specific tasks. So the first function we'll create is def random underscore invert underscore image, and this takes in 2 input arguments x, and the second input argument is value p, which will initialize it to 0.5. Now we'll write a if statement. If tf.random.uniform open close parenthesis square brackets, if this is less than p, that is less than 0.5, then we are going to subtract the pixel values. So we'll replace those values by 255, sorry, 255 minus x, else we return the value as is, and then the function will return x after this subtraction, or the default value is kept as is. Next, we'll create another function def random underscore invert, and again here we'll put an input argument factor is equal to 0.5, and this will return the values as such. Layers dot lambda, we are using a lambda function. Lambda, again another lambda lowercase x colon random underscore invert underscore img x and factor. So with these two functions, we would be able to invert an image. And to plot the image, what we'll do is we'll write the plt.figure fig size is equal to 10 by 10, and for I in range 9, so we have 3 by 3 grid, so we have total of 9 images, and we'll use augmented image. So we'll create a variable augmented underscore image is equal to random underscore invert image, and then we'll use the axis. Ax is equal to plt dot subplot 3 comma 3 comma I plus 1, and then eventual final plot the image. I am show augmented underscore image square bracket 0 dot numpy dot as type uint8. We are taking one of the arrays from the colored image, and we are printing it here, sorry, plotting it. Plt dot axis of, and when we run this, we should see images. So this problem. Okay, found the issue. I missed typing the random invert, so we need to call the function here. So random underscore invert is equal to random underscore invert open close parenthesis, and now when we run this, let's see, there's another error here. Oh right, put the x, we don't need that x. And so now when we run this, we should see, so this is the output that we have, where we have inverted the images. We can continue working through using custom augmentation methods, and the next thing we'll do is subclassing. And for this, we'll create a class random invert, and that takes in input argument layer dot layers colon, and inside of this first we'll have the init methods, def underscore underscore init, and again we'll have self factor is equal to 0.5, then star star keyword arguments. This is the standard method, like a standard way. Super 0 dot underscore underscore init underscore underscore. Again we have star star keyword arguments, and so with this we have, this would be upper, not a 0 there. Okay. And then I type self.factor is equal to factor. Now we can write our method df call self comma x colon return random underscore invert underscore image x. And with this, so layer is not defined. Dy, it should be layers and not layer. So s. And so with this class created, we can use this for plotting. So underscore is equal to plt.imshow random invert open close parenthesis image and then we have the square bracket 0. Now when we run this, we should see an image, and so this is the image that we have inverted as we can see here. Now moving on, let's look at how we can use tf.image to perform data augmentation. tf.image, and for this we'll again load the dataset train underscore ds validation underscore ds test underscore ds and comma metadata is equal to tfds.load, and we'll load the same dataset tf underscore flowers comma split, and here what we'll do is split the dataset as before into 3 sets for train validation and test, and so we need 3 strings here. So I'm going to create spaces for these. So these are the 3 strings. In the first one we are going to type train, and say first 80% goes in the train set, and copy the string, paste it here, and then we are going to say 80% to 90% then goes for the validation set, and then again copy this, paste it here, and then we can say the 90% remaining 10% goes to the test set. That's the split we are creating. With underscore info is equal to true, and as underscore supervised is equal to true. So with that, we now should have our with as super within, we're missing a comma, that there, and so that's how we have now the data set. Next thing is we can look at one of the images. So let's create a variable image, and label is equal to next iter train underscore ds. So what this will do is it will fetch one of the images. Underscore is equal to plt dot imshow, and here we type image. Underscore is equal to plt dot title get underscore label underscore name label, and when we run this, we should see an image that is of tulips that we see here. Next, what we'll do is we'll create a function visualize. So let's create def visualize, and and then this takes in 2 input arguments: original image, and the second is augmented image. And figure, we'll plot them side by side. So figure is equal to plt.figure plt.subplot, that 1 comma 2 comma 1, so 1 row 2 columns, position 1, plt.title original image, and the second is plt.imshow in original. So we are looking at the original image here, and then plt.subplot again 1 comma 2 comma 2 as the second position, plt.title This is the augmented image, and so let's type that augmented image, and we have plt.imshow augmented, and when we run this, that's the function we have created. There's nothing to return in there. And now when we perform the data augmentation, we can use this to visualize two images, the original image and the augmented image side by side. Just so this is like a helper function created. Now in data augmentation, the first thing we'll do is flip an image. And so to flip an image, we'll type flipped is equal to tf.image.flip underscore left underscore right image. So this is a straightforward function. We just say we using tf.image, we can flip left, right, and then we can visualize image, comma flipped, and we should see the visualize probably typo. Yes, the typo. Visualize. Okay. And we see now that this is the original image and this is the flipped image. So the left side flower, that is this one, is now on the right hand side. So we are taking the left side, putting in the right side. So we are flipping it horizontally. Next augmentation we can do using tf.image is grayscale image. So let's say grayscale image, and for this again what I'll do is I'll copy this line of code so we save time typing. This is going to be grayscaled image, and this is tf.image RGB underscore 2 underscore grayscale, and that's image. And again we visualize the image and visualize the squeezed version. So tf.squeeze. So we remove extra dimension, grayscale, because this is grayscaled, and then we also add a color bar. So underscore is equal to plt dot color bar, oh, without the star there. Let's remove the star. Okay. So now we should see we have the original image, we have the augmented grayscale image along with the color bar that is. Next, I will create a saturated image, and so let's give that a heading, saturated image, or saturate an image, and this is saturated is equal to tf.image.adjust underscore saturation, and we input the image and specify value of 3, and again if we visualize image and the saturated image, we should see two images in the output. We have the original image and the saturated image, and if you look at the saturated image, it is more uh, uh, it has more colors in it. The intensity of colors here, these are redder than these, and you see that these small features like the white colors inside of those red flowers, those are lost because we have increased the saturation. After this, we can try to change the brightness. Change image brightness, and for this we'll create a variable bright is equal to tf.image.adjust underscore brightness, and here we input image comma 0.4 and visualize image comma bright, and we should see an image that's brighter than the original image, and so that's what we have. The image on the right hand side is brighter. And the next, we'll try crop, center crop an image, center crop an image. And for this, again, we'll create a variable cropped is equal to tf.image.central underscore crop image comma central underscore fraction. We specify the fraction for cropping, then use visualize image and then the cropped image. And now when we look at the augmented image, we see that it's a zoomed in image of the original image. So these so many useful features and very easy to use using tf.image. Next, let's try to rotate an image. So rotate an image, and here we have rotated is equal to tf.image.rot 90 and image. So we are rotating it by 90 degree. Visualize origin, and this is the image, and then we have the rotated image, and in the output we should see the image rotated by 90 degrees, and that's what we see. We have this image, it's turned 90 degrees, and that's the image on the right hand side. Now there is something called as random transformations, random transformations, and there are several types of these, and we'll look at them one by one in this next section. The first one we look at is randomly change image brightness. So to randomly change image brightness, what we'll do is we'll use, again we are going to use tf.image and then this stateless random brightness. And for that we'll create a for loop for I in range 3. So we'll look at 3 different brightness levels. Seed is equal to I comma 0, and this is so that we get the same values. When we rerun this, stateless random brightness is equal to tf.image.stateless random brightness, and in here we need to input image max underscore delta is equal to 0.95. That's how bright we want to get, and then seed is equal to seed. And finally, we visualize the set with original, visualize image, and then the augmented image is stateless random brightness. Okay. So with this, we should see a set of 3 images, original and augmented. So that's the first one. That's the second and third. So we see that uh, the image brightness was randomly changed, and this again is one way where we can create several augmented image with different levels of brightness just from just one image. Next, similar to brightness, we can also change the contrast of an image, and for that we'll type create a heading randomly change image contrast, and this again is going to be using the stateless random contrast. So we'll create a for loop for I in range 3, and seed is equal to create a tuple of I comma 0, then stateless random contrast. That's what we are going to create. tf.image.stateless random underscore contrast, and here we again input the image lower limit, So we specify lower is equal to 0.1, upper limit we specify 0.9, and here in the help this box we can see the upper is equal to float, upper colon float, upper bound for the random contrast factor, and similarly the lower bound, and then we specify the seed is equal to seed, and finally we can visualize it. So visualize, specify the image, stateless, random, contrast, and when we run this we should see three images, three sets with the varying levels of contrast. So that's the first one, this is the second one, and this is the last one. Three different levels of contrast form the same image. And likewise we can now perform a random cropping, randomly crop an image, and for this we'll again use a for loop. For I in the range 3, seed is equal to I comma 0, that's the seed we are going to use. Stateless underscore random underscore crop is equal to tf.image dot stateless underscore random underscore crop, and again we specify the image, we specify the size, that is 210 comma 300 comma 3, and then we specify the seed is equal to seed. Okay, so with this we already have the parenthesis, and finally we can visualize it. So visualize image comma stateless random crop, and we should see different varying cropped images. Here we have the first image where I think this flower on the bottom right is zoomed in. Then we have the next one is, I think this is this part on the left hand side, and this again is part looks like on the bottom right, the same as the similar to the first one. Now similar, what we have done is we looked at how we can use the tf.image to apply the augmentations to a single image. We'll now look at how we could apply augmentation to an entire data set. And so let's create a heading, call this apply augmentation to a data set. And for this we'll download, get a fresh copy of dataset, train underscore datasets, validation underscore dataset, test underscore dataset, metadata is equal to tfds.load, and the dataset is the same. We have the tf underscore flowers comma split, and again we'll do the split. We'll create three sets. So this is the first one for train, second one for validation, and the third one for the test. The first one will create a string train, and then up to 80% goes in the train set, that parenthesis. Then we have the again 10% goes in here, so 80% colon 90% goes in here, and the remaining 10% train again specify 90% colon, this goes into the test set, and width underscore info is equal to true, and as underscore supervised is equal to true. In the comma, put that there, and so we now have the data set ready. We'll now create a utility function for resizing and rescaling images. So let's call that df resize underscore and underscore rescale, and type in input arguments image and label colon, image is equal to tf.cast image, we are converting it to float 32, load 32, and then image is equal to tf.image resize, and here we input the image and the new size img underscore size and img underscore size. So this would be the new size of the image that is created, and the caps just indicates that it's a global variable. If we create another cell below this and type img underscore size, that's the size we are going to convert it to 180 by 180 pixels. Image is equal to image, we will divide it by 255, image divided by 255.0, and then return the image with its label. Return image comma label. So that's the function we have created. So we write df augment image underscore label comma seed colon, then we have image comma label is equal to image underscore label, image comma label is equal to resize and rescale image comma label. That's the second part, and then we have image is equal to tf.image.resize. What we are doing here is we are using tf.image to resize with crop or pad, and we input the image and the image underscore size plus 6 and image underscore size plus 6. This is what we are doing, the rescaling, resizing, resize with crop or pad, and after that we can create a new seed, make a new seed, and for this we are going to use tf.random.experimental is equal to tf.random.experimental.stateless underscore split, and here we have seed comma num is equal to 1, and this is 0 comma colon. Okay. So that's where we create the new seed, and after that we perform two augmentations. One is crop and the other one is change the brightness. So random crop back to the original size, image is equal to tf.image.stateless underscore random underscore crop, and in here we input image, size is equal to img underscore size comma img underscore size comma 3, and after this a seed is equal to seed. That's the first one, and the next we can change the brightness. So random brightness image is equal to tf.image.stateless underscore random underscore brightness image comma max underscore delta is equal to 0.5. Seed is equal to new underscore seed, and finally image is equal to tf.clip underscore by underscore value image 0 comma 1, and after that we'll return the image with its label, return image comma label. So that's our augment function that we have created. Now what we'll do is we'll apply all of these to the train dataset and the test dataset. And before we do that, we'll create experimental counter. So that option 1, have 4 hashtags. Option 1 using tf.data.experimental.Counter, and for this what we'll do is we'll create a counter object and data set.zip, zip it together with the training set. So we are going to combine the train data set and the counter. Counter is equal to tf.data.experimental.Counter and train underscore dataset ds is equal to tf.data.dataset.zip, and this as train underscore data sets that we have earlier, that we had created earlier when downloading the dataset, and then we have this counter comma counter. With this dataset now, when we try to apply it to the training dataset, let's say put a heading a the augment map the augment function to the training dataset. And here we have train underscore ds is equal to train underscore ds, and then we are going to do a dot chain. We are going to chaining on this, a dot shuffle 1000, then dot map augment comma num underscore parallel underscore calls is equal to auto tune. Then we have dot batch, that's the batch size, batch underscore size, and then again we have dot prefetch, and parentheses we have auto tune. So that's what we have for the train dataset, and when we run this, an error has no app. Oh, so there's a typo. Um, experimental. The yep, that's the typo there. We go back all these cells, and okay, so this is running fine. What I'll do next is copy this, and we have to apply this to the validation and test set. So this is going to be bal underscore ds, and then again this is going to be bal underscore ds. You do not need the shuffle, you just need the map, resize and rescale, then parallel calls is equal to auto tune, batch, and then prefetch. Likewise here we just need this to be test, and this would be test as well. We do not need the shuffle, we delete that, and this way there's an error in both of these. Let's see what that is. Okay, so found the problem. This should be resize and rescale, resize and rescale. Run that, and likewise this needs to be resize and rescale, and we run that. So that was the option number 1, where we use the experimental counter to augment the data set. The next option that we'll look at is using random generator. So this is option 2, which uses using tf.random.generator, and for this what we'll do first is we'll create a generator, create a generator. RNG is equal to tf.random.generator.from underscore seed 123 comma alg is equal to philx. So that's the algorithm, and then we run this, we get the range. Now what we can do, we can create a function for updating the seeds. So create a wrapper function for updating seeds. tf f x comma y, and seed is equal to rng dot make underscore seeds 2, and we put open close parenthesis, and then take the value of index 0. Image comma label is equal to augment, and then we specify x comma y and seed. So this augment, so if we go back up, we have this augment. It takes the image label and seed, and likewise we are passing these values, this tuple in there for the image label. So if you go back up, image label then gets decoupled into image and label. So those two values are going in there, and then we have the seed, and then we return image and along with its label. That's f of x. Now we can use this to with a train and test, a train validation and test data set. So we'll say map. What we are doing is map the wrapper function f to the training data set, and that's one. And then second, we are going to resize and rescale function to the this is going to the validation and test sets. Two different things. The train underscore ds is equal to open close parenthesis. Here we have train underscore data sets, and then we do a dot shuffle 1000. Then we have dot map. This is going to map on the function f num underscore parallel underscore false is equal to auto tune, and then again we do a map batch, and then we have batch underscore size, and again we have dot prefetch auto tune, and that's the first part. um, there's a typo, need l, as that's a train underscore ds. Likewise we would have the validation underscore ds. Val underscore ds is equal to open close parenthesis, again val underscore dataset, then we do a map dot map, and here we are not using f, we are using resize and rescale comma num underscore parallel underscore calls is equal to auto tune, then map batch underscore size, and finally dot prefetch auto tune. So that's our validation, and same thing for the test set. So I'm going to copy paste it here and simply change these to test, and that's our test set. So these are the train, validation, and test sets that we have created, and that can again be used to train a model as we did before. So if we scroll back up, we go all the way up. So this is the model that we had, and those were train, validation, and test sets. So what we can do is can try and copy this and paste it here. So that's we are okay. Never mind. Delete this. We can directly try to run this on a train. So that's the model. Copy the model, paste it down here. The model we have, and then we scroll back up and get this compile model.compile, and then we'll go back one more time get the values for the final train and copy this. So we have the epochs and the model.fit. And when we run this, this is running through, it'll take some time. Welcome back. The run is completed, and here we see that the validation accuracy is 0.65 as compared to 65. I think what we had earlier was in similar range, 0.65485 something. Yes, so that was the accuracy we had on the test set. Let's run this on the test set. And before we run that, I just wanted to show the two changes I had to make in the code. One is added this input shape argument right here in the model, and here in the function that we created, the function f that we had created, here I added this line of code which is reshaping the image, and that is to avoid the error for shape mismatch between this model and the trained data set that was created in this last option method that we looked at. And when we run this now for the test set, we should see some level of accuracy, and it is little less than what we had earlier, but that's how we can create, we can take an image, we can perform augmentation on the image, we can rescale the images, we can crop, we can change the brightness, we can change contrast, rotate the images, and all of these things we looked at in this particular video with different uh, methods, different options we have. There's tf.image, we created custom methods as well. And I'm hoping that in this video you got a very in-depth review on how we can augment images, how we can augment data in TensorFlow. And once again, if we scroll back to the beginning of this notebook, uh, please look at the TensorFlow docs, which is at this link below, and the entire code in this particular video was directly copied from those docs. And all I did was try to explain as we go through each of the line of code so that it may help you understand the code better. If you have any comments or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Please like, share, and subscribe as it helps me stay motivated to create more content for you all. Thank you.